Techniques and properties of matter, A Factor Academy. We'll be looking at solutions to different problems on distance and displacement. Okay, so what is distance? Distance is total length of the journey, and it is a scalar quantity, while displacement is the shortest distance between 2 points. Shortest distance between 2 points. Okay, so let's look at this question. Question number 1. We have to calculate the displacement that will be needed to get the ball into the hole on the first stroke. If a golfer takes 3 strokes, okay, 3 strokes to get the ball into the hole once he's on the green, given that the first stroke displaces the ball 6 meter north, okay, second stroke 6 meter north, second stroke displaces the ball 3 meter southeast, okay, and the third displaces the third stroke 2 meter southwest. Okay, so let's see the solution to this problem. Now to solve this problem, we have this cardinal element. This is the north, here is the north, so we have the south, we have the west, and here is the east. Okay, so let's see what happens. Now, and this is the ball. This is the what? This is the O, rather. This is the O that we want to get the ball into. Okay, so instead of this is the starting point. Okay, so is the ball is supposed to go into the O straight, but instead the golfer decided to take the stroke. Let's take 3 strokes from here. One north, another one south east, the other one southwest into the ball, into the hole. So one north, one here, one here. So let's see what that is. So here, this is another element, cardinal element. So north, south, west, and east. So this is it. The golfer displaces the ball. The first stroke is what? 6 meters north. So this is 6 meters north. So the first displacement of the ball from this starting point to this point is 6 meters. Now, then after that, the second stroke is what? 3 meters southeast. Now, because it's southeast, it will be what? Exactly 45 degrees from here. So we have this is what? From the south. So exactly 45 degrees from the south, and this is what? Southeast. So we look at this is what? The second displacement is 3 meters to this point. Now, the last one is now 2 meters southwest. So this is what? Southwest. Okay? Southwest. Okay? So this is southwest. But it's 45 degrees southwest. That means 45 plus 5. Then we have this. This is also what? 45. 45 degrees. 5 degrees. Okay? Because it's what? It's southwest. Alright, so then get the ball into the hole. So this is the ball now in the hole. Now, the question is, what is the displacement that will be needed to get the ball into the hole on the first stroke? That is, if you have to play the ball from here to here, what will be the displacement? Because displacement is what? Shorter distance between 2 points. Here is what? The starting point, and here is what? The destination. So here is the starting point S, and here is the destination D. Here's destination D. So this is 2 meters, okay, south west. Now let's look at the components of all these what? Displacements. Okay, because displacement is a vector, so it can be resolved into 2 components based on this question. So we have the horizontal component and the vertical component. So we have the vertical component, the horizontal component. Since this one is S2, let's say this one is what? S2S. Okay. and here is what? S2y. All right. Now, also the component of this, we had what? Vertical and horizontal component, S3y, and what? S3x. So now we now have the displacement of the body. So let's explain this. Raise all in. So we have displacement. So here is displacement S, which is social distance between 2 points, the starting and the destination, the O. Now, what is the angle of displacement here? We don't know. But this one too can be resolved to two components, horizontal component, which is going to be what? The resultant of all horizontal components, okay? S1, S2, S3, that's the addition of all horizontal components, okay? That's talking about the what? The resultant, okay? The S. Now, we also have summation F sub y, which is what? The summation of all vertical components. And that's what we're doing. So let's go. Now, this is a very good interpretation of the question. This is a very good interpretation of the question. Now, with this interpretation, let's see what we are going to be doing. Now, to calculate the displacement that will be needed to get the ball into the hole on the first stroke, which is S, summation of this, okay, which is summation S of x for all the x components of all the displacements is going to be the horizontal component here, which is 0, okay, for the 1, okay, plus what? This is moving in the positive x direction, so that's why it is plus S2x, and here is moving in what? Negative x direction, that's why it's what? Minus S3x, okay. Now, if you look at this very well, this angle and this angle are the same, okay, so that means S2x is going to be what? Going to be S2, okay, then cos theta, okay, and S2y equals to what? S2 sine theta, So let me just call it theta 2. Theta 2. Okay, because this is what? Let's take this one as our theta 2. Theta 2 for 5 degrees. Okay. Actually, we are actually dealing with what? Horizontal components. Okay. So we can actually clean this. We can clean this and give, okay, and give this. This is not the angle. But dealing with the horizontal component, this x2, and theta 2. So theta 2 is also going to be what? 45. Okay? Theta 2 is also going to be 45 because the whole of this angle is 90 degrees. So if this place is 45, then this place is also what? 45. Okay? Here, this is horizontal inclination of this S3. Okay, so S3x will also be equal to S3, okay, cos theta. Don't forget, here theta is what? Horizontal inclination of S3. Then theta 3, okay, and S3y will equal to what? Will equal to S3 sine theta. That's theta 1, theta 3. Okay, so this is very important to know. Meanwhile, note that theta here, that's theta 2 and theta 3 is horizontal inclination, horizontal horizontal, okay, horizontal angle of S2, which is the same for S3 as well. All right, so this is what we are doing. So this will form a very clear basis for what we are solving in this question, which is very straightforward. So let's take all this out. Now that this is clear, let's take all this out, erase all of this. Now, so we know that S2x is what? 3 cos 45, okay? And S3s moving in negative x direction, so which is minus S3 being 2 cos 45 degree equals to what? Equals to, that will equal to 3 cos 45 is 2 over 2 plus the minus 2, the 2 over 2, okay, plus 0, which is out. So we have this is 1.5 with 2 minus root 2, which will give us 0.707 meter. So this is the resultant of all the horizontal component of displacement. Now let's go to the next one. For the vertical component, total vertical component will also be all the vertical components, which is this one is moving down, here's another one moving down, okay? Addition of these two will also give us the total vertical component of the displacement, and this as well. Okay, so let's look at it. The body is moving up here, so that means it's moving in the positive y direction. Okay, positive y direction. So this is plus y. So here is plus y. Why this one is what? Moving down, which is what? Minus y. Here is also moving down. Here is also moving down. This is what? Minus y as well. Okay, minus y as well. So let's go down. So summation of all the vertical components will now be what? Minus, which is this one is minus s2y, okay, plus s3 plus minus s3y, okay. Then this one is going up, is plus 6. So let's go. Now s2y, of course, because it's y, okay, that means we're looking at the horizontal inclination, and we have y, that will be what? S2 sine the horizontal inclination theta 2. Okay, so what would that be? That would be minus 3, because this is going down, so minus 3 s2 sine the angle, horizontal angle, 45 degree. So automatically that's why we have this here. Next one is also going down, which is s3y, that will be minus 2, that's s3 sine the horizontal inclination, which is this angle here, and that will give us minus 2 sine 45 degree. Now plus 6, because this is also vertical, only vertical component is moving up, and it's positive. That means it's moving in the positive direction, positive y direction. Okay, so now let's solve all these parameters, all this sine, all this trigonometry. So we have minus 3 sine, minus 3 root 2 plus, then we have minus 2 root 2 over 2 plus 6. Now solving this is going to give us minus 1.5 root 2 minus 2 minus root 2 plus 6. So eventually solving this will give us 2.464 meters. Now that's not all. The next thing we are doing now is to solve for what? The value of the displacement from the starting point here to the what? To the O on the green. Now to do this, we use Pythagoras rule. Why? Because we know that what? Here we have summation s of x and summation what? Summation s of y. Okay? So if you have to solve for what s is, using Pythagoras rule, okay, we have this. You're going to be having something like this, where this is theta, Okay, so here is going to be what? S of y, summation S of y, and here is going to be what? Summation S of x. And here is what? Our s. So Pythagoras rule, that's why we have this. So s now equals to summation square root of the square root of the sum of the squares of the summation s of y and summation s of x. Okay, so what is summation s of x? 0.707, okay, which is same thing as 0.5 root 2 all squared plus, okay, there's 2.464 all squared. So solving this, we have a final answer for s to be 2.564 meters. Okay, now to get the direction, okay, first of all we need to get the value of theta. And why is theta the most important thing for direction? Because if we have to look at this, taking the north as a reference, here is the north, is that not? So that means coming from here is going to be north, whatever this angle is, in the direction the body is going to, which is what? Direction of the what? Direction of the east. So let's solve this. Now, recall that our tan theta is what? Tan theta is what? Opposite over adjacent. Okay? And here, if this is the angle, the opposite is what? This is the side opposite it. Okay? That's the side opposite this angle, which is the summation of what? S of x. Okay? Because this one and this one are parallel to one another, and they're taking equal based on the fact that opposite sides in a parallelogram, okay, in a square like this are equal. So if this is parallel to this, then these two are equal. This is also parallel to this, then this one are also equal. Okay, so now let's make our coordinates. Now we have this. So we want to get theta. Theta is going to be what? Tan inverse of both sides. We have theta equals to tan inverse of what? Summation of s of x the summation of s of y. Okay, now what is summation of s of x? Of course, s of x is going to be this. Okay, that's 0.5 root 2, and s of y is 2.464. Okay, now solving this, tan inverse of this, press this calculator will give us 16.01. So final answer, the displacement that will be needed to get the ball into the hole on the first stroke will be what? This is the magnitude, and here the direction, which is what we need to solve this problem. It's as simple as ABC. Thank you very much. If you have any other question to ask, feel free to comment. If you have any other suggestion to add, also comment. But don't forget to like, share, and subscribe. Thank you.